Hello everyone. In the previous video we discussed about the basics of this chapter, which is motion in a straight line. We discussed about what is rest, what is motion. Then we discussed about the distance and displacement, and what is scalar and vector quantities. We know the distance is being a scalar quantity, it can never be zero. Displacement being a vector quantity, it can be zero. Similarly, we discussed about average speed and average velocity also. We saw some shortcut formulas to to calculate average speed and average velocity if the distance is same. After that, we discussed about uniform velocity, we discussed about variable velocity, and average velocity is what? Total displacement by total time taken. After that, we proved v equals to u plus at. How we can prove the with the help of calculus method. V equals to u plus at we proved. Then we proved s equals to ut plus half at square, and we proved v square minus u square equal to as. These three equations we have already proved in class 9 also, but not with the calculus method for sure. Calculus method we are using in class 11 only. In class 9 we used to use that graphical method, so I think we can skip the graphical method now, but that is there in the syllabus. So I will ask all of you to just solve these 3 equations and 4 equations with the help of the graph. If you can prove it, it is okay. If you cannot prove it, just let me know. I will make a separate video for that. And then we had one new equation that if you want to find the distance traveled in a particular time, in a particular fraction of time, in a particular instant of time, which was s nth equals to u plus a by 2 into 2n minus 1, where s nth is what was that the distance covered in nth time. Not suppose if I tell you distance covered in 3rd second, distance covered in 5th second, not 5 second, then we can use this formula, which was equals to u plus a by 2 into 2n minus 1, where u was initial velocity, a was acceleration, and n was the time in which we are finding it. So here we have one numerical which is based on this formula. The distance covered in second is given as 12 meter, and the distance covered in 4th second, particularly in 4th second only, not in 4th second. Similarly here also the distance covered in second, not 2 second, is given by 12 meter. The distance covered by in 4th second is given as 20 meter. So how much distance will it cover in 4 second after the 5th second? So after 5th second, what is the 4 seconds? 6, 7, 8, 9. So what they are asking basically to us, they are asking basically S9 minus S5, because after 5th second, what are the 4 seconds? 6 seconds, 7 seconds, 8 seconds, and 9 seconds. So we need to find basically S9 minus S5. You can see here, after 5th second, this is what we need to find. So if we can find total distance from here, and if we can subtract from total distance from here, then also we can do it. But to do that, we need initial velocity and acceleration. To get that initial velocity and acceleration, we will use the formula. We know s second equals to 12 given, and the formula is what? U plus a by 2 into 2n minus 1. At the place of n we can write 2, so it will be 2 into 2 minus 1 equal to 12. So u plus a by 2 into 3 equal to 12. If we take LCM and all, we will get a linear equation which is 2u plus 3a equals to 24. After that, we had one more equation, we had one more information that s fourth equals to 20. We can use that also, and you can see here u plus a by 2 into 4 minus 1 equals to 20. So we are getting 2u plus 7a is 40. So these two linear equation we can be treated as simultaneous linear equation, and we can get small a and small u by solving these two simultaneous linear equation. A we will get as 4 meter per second square, and u will be getting as 6 meter per second. Now what was our work? Our work was to find S9 minus S5. So this is S9, not 9th. So we are using formula S9 equals to ut plus half at square here. U we know, time we know, it is 9 seconds. We'll put all these values, we'll get the result as 216 meter. After that, we'll find S5 S5 also we will get the value is 80 meter. So what is the distance covered in the 4 second after the 5th second? So the distance covered in 4 second after the 5th second will be S9 minus S5, which will be 216 minus 80 equals to 136 meter. This is clear to everyone, I guess. Okay, so after this we need to focus on graph. We have different kinds of graph. If you talk about position time graph, it can be distance time graph or displacement time graph. And if we talk about there can be more graphs: speed time graph, velocity time graph. Let us first go for the position time graph, which can also be taken as distance time graph. So if we take position time graph, suppose I'm taking distance time graph, and one more I'm taking displacement time graph. This is displacement, this is also denoted by S only. So how can we show a body which is at rest in distance time graph? So if a body is at rest in distance time graph, it means what? With the change of time, the distance is not changing. So this will be the graph for distance time graph if the body is at rest, and similarly for displacement time graph also this will be there, because any change in distance and displacement we need to show vertically. If there is no vertical motion, we can say there is no change in the vertical thing, that is the distance and displacement is not changing. So so we can say that the body is at rest. After that, uniform motion. What is uniform motion? If a body is covering equal distance in equal interval of time, then we can say that the motion is uniform motion. So how we can show uniform motion in distance time graph? That is also very easy. You just need to show like this. This line will be showing the uniform motion and a distance time graph or displacement time graph. If it is a non-uniform motion, we can go like this, or we can go like this also. Similarly, if it is a non-uniform motion, we can go like this, we can go like this also. This is non-uniform motion which the speed is increasing. This is non-uniform motion which the speed is decreasing. But after each and every graph, we need to find the slope and area. So how to find the slope of any graph? To find the slope of any graph, what we need to do basically, we need to divide the y-axis component with the x-axis component, and if we need to find the area, we need to multiply the y-axis component with the x-axis component. So here if we find the area, y-axis component is distance and x-axis component is time. So if we multiply it, if we try to find the area, if we multiply it, I think we will not get any valuable thing, because we know that distance into time is not any particular thing. So but if we find the slope, so here if we find the slope, it will be distance by time, which will be speed. And if you find the slope of a displacement time graph, it will be displacement by time, which will be velocity. So the slope of distance time graph gives us a speed, and the slope of displacement time graph gives us velocity. Okay, so this is clear. This is what we have studied about the position time graph, or we can say distance time graph and displacement time graph. After that, we can shift to speed time and velocity time graph. So if it is a velocity time graph, what we can do here, if the body is moving with constant velocity, then how we can show if the body is moving with constant velocity? It means with the change of time, the velocity is not changing. So we can say like this. But when we showed the body is moving with constant velocity, constant speed here, in case of distance time or displacement time graph, we showed it by the straight line which was passing through the origin. But in case of velocity time graph, it will be different. In case of velocity time graph, if a body is moving with constant speed or constant velocity, we need to show a parallel line to the x-axis, because we know that if a body is moving with constant speed or constant velocity, then what does it mean? That with the passage of time there is no change in velocity, so there will be no vertical motion, it will be going parallel to the x-axis. But if a body is moving with uniform acceleration, that it is changing equal velocity in equal interval of time, then it will be a straight line passing through the origin. Okay, and this is also known as slope. If a body is moving with uniform acceleration, then we need to show a straight line which is passing through the origin. And if the body is not moving with uniform acceleration, if it is a non-uniform acceleration, non-uniform increasing or accelerated motion, then we need to show like this. Non-uniform decreasing or deaccelerated motion, then the graph will be like this. Again, here also we will find the slope and area. If we find the slope of a speed time graph, then it will be speed by time. It is nothing, we don't know anything quantity, it is speed by time. But if you find the slope of a velocity time graph, it will be velocity by time, which will be acceleration. Similarly, if you find the area of speed time graph, it will be speed into time, which is given as distance. And if you are finding the area of velocity time graph, it will be velocity into time, which will give us displacement. So this is the basic difference between speed time graph and velocity time graph, but the nature of the graph will be somehow little bit same. So this is what we have studied in this chapter, and if you want to go for some numericals, you can try some numericals by yourself, and you can come back to me if you are not getting the solution of any kind of numericals. Some numericals I have done in the class that I want to show you right now. So all of you can see one numerical I did here, that if a body is covering the first 2 meter in 2 seconds, then 4 meter in 2 seconds, then 1 meter in 2 seconds, then what is the average speed? So we can say here is the first we will check that the body is moving with uniform speed or variable speed. So we will see here the body is covering 2 meter in the 2 seconds. Here the time is same but the distance is different. Again the time is same but the distance is different. So we can say the body's speed is not fixed, that is, it is not moving with constant speed, it is moving with variable speed. Here the speed is 2 by 2, that is 1 meter per second. Here the speed is 4 by 2, that is 2 meter per second. And here the speed is 1 by 2, that is 0.5 meter per second. Now if you are being asked to find the average speed, so what we will do? Total distance, that is 4 plus 2 plus 1, by total time taken, that is 2 plus 2 plus 2, 6. So it will be 7 by 6 meter per second. We will do the total speed here. So total average speed here. But suppose the body is going to this and coming back to this, then what will be the average speed? If you need to find the average speed, then we need to add everything. Okay, but what will be the average velocity at that time? As I told you, the body is moving from this point to this point through this also, that it is covering unequal distance in equal interval of time, but it is again coming back to the same point. If it is again coming back to the same point, then the displacement is being 0. So if the total displacement is 0, then the total average velocity will also be 0. This we need to understand. After that we have one numerical here. A cyclist moving in a circular track of radius 100 meter completes 1 revolution in 4 minutes. What is the average speed? average velocity in one full revolution. So the cyclist is moving in a circular track of radius 100 meter. Then we need to see if it is taking a complete turn, then we need to see that what is that, if you want to find average speed, we need to see that what is the total distance if it is covering a full circle. So if we know that if it is covering a full circle, so in order to find the distance, what we need to find, we need to find the perimeter actually. So if you try to find the perimeter, it will be what? It will be 2 into 100 into pi. So it will be 2 pi r, which is the perimeter. Okay, and so we have the speed, we have the average speed formula, total distance by total time taken. So the total distance is what? One complete revolution, that is what? That means what? 2 pi r divided by total time we need to do. So what is the total time here? 4 minutes. 4 minutes must be converted into second. So it will be 4 by 60. So if you find from here, it will be 5 pi by 6 meter per second, the average speed. But what will be the average velocity in this case? In this case, as you can see, the body is completing one complete revolution. That is, what does it mean? The body is coming back to the same point after completing one revolution. So can we say that the total displacement is 0 or not? That if the total displacement is 0, then what will be the total average velocity? Average velocity is what? Total displacement by total time taken. That will also be 0. This is very simple, I guess. After that, one question is there. If a body is covering one half of a journey with a speed of 40 km per hour and the other half of the journey with a speed of 60 km per hour, then what is the average speed or average velocity? In order to do sums like this, in which the distance is same because it is covering one half and one half, and if it, or it can be one more case that the body is going from this point to that point and coming back to the same point. In that case, the second case also, the distance covered will be same. So in order to find the average velocity or average speed of these kind of cases where the distance is same and it is divided into two parts, and if the speed is given of the two intervals, then we don't need to use that formula that average speed is equal to total distance or total time, because then we need to find total distance and total time. We can directly use the formula 2b1 b2 by v1 plus v2. So it will be 2 into 40 into 60 by 40 plus 60, and by solving that we will get it as 48 km per hour. So this is a very much shortcut method in compared to that traditional long method. So we can do this, but we cannot do this in all kind of cases. We can do this in those cases only where the distance is being same. Suppose if it is being divided into 3 equal parts and all the equal parts having same distances, then the formula is different, which is what? 3v1 v2 v3 by v1 v2 plus v2 v3 plus v3 b1. So these are the things that we can do it simply, but this is very special. This is a special case only because we cannot do it with all the numericals of average speed and average velocity. We can do this with those cases only where the distance is being same. So we have we have just finished all the topics which is there in the chapter, in syllabus from this chapter for this semester 1 or term 1. The topics were, I repeat, the topics were elementary concept of differentiation and integration for describing motion that we did. Uniform and non-uniform motion, I think now we know. Average speed and instantaneous velocity, that also we discussed in the previous video. Uniformly accelerated motion, that also we did. Velocity, time and position time graph, that is also done. Relations for uniformly accelerated motion, that is also done. So according to me, whatever theory and derivation and the basic numericals were required in this chapter, that we have covered. But after that also you do some numericals by yourself, you do some derivations by yourself. In case if you find anything which is not covered in those two videos, then you can come back to me, you can message me, I'll get back to you, and I will try to go for a separate video for all your doubts. One more thing is there, that graphical treatment of those 3 or 4 equations, you can prove it by graphical method, that we have already done when in class 9. So I tell you that you try to do by yourself. If you cannot do, then you tell me, I will try to do it. I will try to make one separate video for the graphical treatment for the proof of those phi b equals to u plus at, s equals to ut plus half at square, and v square minus u square equals to 2as, which we have already done with the calculus method, but we need to do it with the help of graphical method also, because that is also there in syllabus. And one thing you must keep in mind, if you are finding the slope of any graph, you must divide y component with the x component. If you want to find the area of any graph, you must multiply y component with x component. So with this and with some positive thinking, I'm just positive feedback, I'm just closing this video. This video is over. Whatever queries, whatever doubts you will have, you can post me in my WhatsApp. I will go through that. Thank you all of you.